Here's integrated one mini lecture for your packet for 11.2.1. Don't forget to look in your book. There's math notes boxes and things. But basically we're assuming that you've heard of this distance equals rate times time. Some people say they say dirt. So we can use different variations of this to solve these different work problems. We could say rate times time equals jobs, right? Because that's however fast you go times however long you work is going to determine how many jobs you get done. So this is actually what we're going to use for our work problems. And it explains it over here. We're also going to do some mixture problems. I don't know if it'll be in this video or the next video. So here's some nice examples. I'm not going to go through those because I think you can read them on your own. I'm just going to do as many problems as I can until I run out of time on my video. Okay, so let's set this thing up. It says Susan can paint her living room in 2 hours. That's actually a rate. You know how, like, you guys will say miles per hour. You know that's a rate. That's a speed. It's how fast you're going, right? Miles per hour. Well, so it's always something per unit time. So we can say her rate is 1 living room per 2 hours. I know that seems weird. Or, in other words, if it's 1 living room per 2 hours, then isn't that half a living room per hour? Because if it takes her 2 hours to paint 1 living room, then it takes her half an hour. I mean, it takes her an hour to paint half of the... After an hour went by, she's only got half of it done. So that's her rate, okay? But we're gonna add that to the rate of her friend. So up here I'm thinking rate times time equals jobs. Okay? That I'm kind of filling in just kind of like, well, like that, rate times time equals jobs. Okay? So her rate plus her friend's rate times however long they work together is going to equal how many jobs. In this case, they're only doing 1 job. All they're trying to do is paint the 1 living room. There's just 1 living room to paint. So Susan can paint her living room, 1 living room in 2 hours. The rate of Jamie is, or I guess it's Jaime, take him 3 hours so he can do 1 room in 3 hours. Or you can say he can do 1/3 of a room per hour. If they work together, how long will it take them to paint the living room? So rate times time, I'm just going to use a T for time, equals jobs. Okay? So how are we going to do this? Well, I can add these pretty easy. I'm kind of okay at common denominator thing. This could be 3/6. Remember, because you have to get the common denominator. What's that going to be? 3 times 2, 1 times 6, 2/6. Right, and then that's going to be, well, 3 plus 2, that's 5/6 times time equals 1. Now, how on earth am I going to get the t by itself? Some of you guys are going to say, let's divide both sides by 5/6. And that's okay. You can, but remember when you divide, you flip and multiply, like when you're doing fractions. The more algebraic way to do it would be to multiply both sides by the reciprocal, which is the same thing as flip and multiply, right? Because if I wanted to divide 1 by 5/6, wouldn't I have to go 1 times 6/5? So these cancel out. And then what's 1 times anything? Or what's anything times 1? It's itself, right? 6/5. 6/5, I don't know, I'll put it in my calculator. It's 1 and 1/5. 1 and 1/5, that's probably 1.2. Let's see. 6 divided by 5. That's 1.2. 1.2 hours. Okay? And they show you the answers. There's a nice little, let's check our answer. I mean, they don't show you all the algebra that you have to do, but they show you how to set it up, and I think they do a good job. This is rate. That's what those fractions, that's time, that's jobs. Okay, so let's try, I still have time to do number 4. Number 4 says, together two machines can harvest a tomato crop in 6 hours. So I know rate times time equals jobs. Okay, there's time is going to be 6 hours, and it's just a tomato crop, right? Can harvest a tomato crop, so that means 1 tomato crop. Okay, and there's 2 machines, so it's going to be like the rate of the first machine plus the rate of the second machine. And they're going to, in 6 hours, they're going to harvest the 1 tomato crop. So let's see. The larger machine can do it alone in 10 hours. So that means the large machine, its rate is 1 tomato crop in 10 hours, or 1/10 of a tomato crop per hour. How long does it take the smaller machine? Well, it looks like that's going to have to be X, huh? We'll just call it X, because we don't know. Okay, so don't cry. It's okay, you can do this kind of math. This is not hard. I want to get X by itself, so I'm going to do algebra. I'm going to divide both sides by 6. See, that's not that bad, 1/6. I got some fractions. I'm not scared, I like fractions. Now you can do that thing where you do fraction busters and multiply by 60 and get all the fractions away, or I don't know, I feel like since this is kind of a small problem, I feel like I could just go, maybe this is a little simpler. Because you're still it's still the same amount of work. What's 1/6 minus 1/10? I don't know. I got, common denominator could be 30? 10, I don't know, 30 would be a good common denominator. Well, 10 times 3, 6 times 5, there we go. 5/30 minus 3/3, that's a minus sign. 5 minus, that's 2/30, and that would reduce down to 1/15. So the rate of this machine, the smaller machine, is they can do 1 crop in 15 hours. So that kind of gave us our answer. It's not 1/15. The answer is how many hours, or how long until this smaller. How long does it take for the smaller machine to harvest the crop? So you're gonna say 15 hours. Make sure that we answer the question. Yep. I don't know if I have time for another one. I think this will be a 2-part video. I'm gonna do number 6. I think I can do it, and then I'll do a mixture problem in the next video. So number 6 is about a water tank. It's filled by 1 pump in 6. The water tank is filled by 1 pump in 6 hours and emptied by another pump in 12 hours. If both pumps are operating, how long? So this one's a little more interesting. I know that rate times time equals jobs. Okay, so it's just 1 tank that's getting full, so I know that's going to be a 1. Now, I think I can figure out some of the rates. Filled by, so 1 pump, so this first pump, it can fill it up, and it can fill up 1 tank in 6 hours. And this one can empty 1 tank in 12 hours. I got it. Empty 1 tank in 12 hours, right? Because the minusing, they're working against each other. And then I'll just put in T for time. And then I can, you can notice I'm running out of time. This will be 2/12 minus 1/12. That's 1/12 T. equals 1. So t is going to equal 12 because I multiplied both sides by 12. Ta-da! Let's check it real quick. Yep. Okay, I'll make it a part 2 for this.